Now, under the heading Simple Examples on Probability, the first problem goes like this. A box contains 100 tickets numbered 1 to 100. A ticket is drawn at random. Find the probability that the number on it is a, and now you have 3 different events. So when some example like this is given, your thinking goes in this manner. First, you see what is the experiment here. And for that experiment, how many possible outcomes are there? So you are thinking about, this is thinking process. Huh? You are not writing it. You are thinking about the experiment. Then you are thinking about the sample space, which is S. And then you are actually trying to find out what is NS. Now, in many of the problems, writing down the elements in the sample space is not possible because of the big size. And anyway, that is not required for the calculation of probability. What is required is NS. Okay, so this is what is the first thinking you have in your mind. Then you go to the events. Different events are given here. So for each event, out of this sample space or out of these possible outcomes, what are the favorable outcomes? And then you think about the event, that is event A, let's say, if you name it something like this, and then you think about N of A. So this is how the thinking process goes on. Let us apply it to this problem. Now here the experiment is you are selecting a ticket, okay, from a box which contains 100 tickets numbered 1 to 100. So your S, experiment is selecting a ticket and sample space S will contain the numbers 1, 2, 3, 4, 5, 6 up to 100. So obviously we are not going to write the sample space S, but we will write down NS. So when, and also remember, we have learned combination in the prerequisites of probability. So selection is combination. This is another thinking which happens in your mind. And when you are selecting just one object, see, from n objects, if you are selecting, selection is C, one objects, it can be done in how many ways? It can be done in NC1 ways. But you know that NC1 is nothing else but N. This is another formula which you have in your mind. And therefore, when one object is drawn in any example, we actually don't use the combination ka formula because NC1 is N. Therefore, my NS here is, so here my NS is going to be 100. Correct? Now, let us come to the events. The first event is perfect square. So what you have to do is now, you can write the answers here itself, probability of perfect square. And write down the definition as I always tell you. Definition is NA upon NS. This is the definition you always write. Now you may feel that there is a mismatch. In my bracket, I'm writing event as perfect square and in the formula, I'm writing NA, but that is okay. This is a general definition we are using. And as I told you, it is not necessary to define the event by some alphabet or something. You can directly write the description of the event in the bracket. That is okay. You can save time in that particular thing. Okay. So this is the definition. And now, as I told you, the denominator is going to be fixed, that is 100. Now we want to see what is the numerator. So for that, we will count how many perfect squares are there from 1 to 100. So let us count it. So you all can see that from 1 to 100, there are 10 perfect squares. This can be counted in other way that 1 square is 1 and 10 square is 100. So 1 to 10 के squares 1 to 100 के बीच में है. So how many are there? They are 10. So I write it as 10 and the answer is 1 by 10. This is my answer for the first question. So probability of perfect square is 1 upon 10. You can either write it in the numerator upon denominator form, or you can write it in the decimal fraction also. Anyway, it is allowed. Please remember one very important point before we solve more examples on probability, that probability of any event always lie between 0 and 1. So any problem you are solving, you will never ever get a negative answer, and you will never ever get an answer more than 1. Keep this in your mind always. Okay, now let us look at the second question. Now for second question, probability of a multiple of 16. So a multiple of 60. So again, write the definition Na upon Ns. Every time you write same definition. And then immediately you can write Ns is going to be 100. As the experiment is not changed, the denominator Ns will not change. Now for the numerator, what you have to count is how many multiples of 16 are there from 1 to 100. So म्हणजे तुम्हाला थोडक्यात 16 चं टेबल म्हणायचंय. 100 क्रॉस करायच्या आधी किती येतात numbers. So can anybody tell me?
6.
So 96 येतात, म्हणून multiple of 16 which are lying from 1 to 100 is 6, because 16 6 are 96. Correct, no? So the numerator is going to be 6. And the final answer is going to be 3 upon 50. You can keep again as the numerator upon denominator, or you can convert it into the decimal fraction if you are using the calculator. Now in the similar manner, let us see the third problem. Now the third question is about a prime number. So you have to find the probability that the number on it when a ticket is drawn is a prime number. So probability that you have a prime number is, again the definition, Na upon Ns, denominator is going to be 100. Now the question is, how many prime numbers are there from 1 to 100? Now what are the prime numbers? Prime numbers means they have only or exactly two divisors, the number 1 and the other divisor is itself. म्हणजे थोडक्यात त्यांना कोणत्याही दुसऱ्या नंबरने डिवाइड करता येत नाही, एक्सेप्ट 1 आणि तो नंबर इटसेल्फ. जसा 2 आहे, 1 is not a prime number. Smallest prime number is 2. 2 आहे, 3 आहे, 5 आहे, 7, 11. आता तुम्ही काउंट करायचं किती प्राइम नंबर्स आहेत. इथे तुम्हाला ऍक्च्युअली काउंट करावं लागणार आहे. 1 to 100 के बीच में कितने प्राइम नंबर्स है. So one can note down that the prime numbers which are lying between 1 and 100, if you make the list, this is the list of prime numbers, and how many are they? They are 25 in numbers, and therefore in the numerator you have 25 here, and the answer is 1 by 4. So this is how you get the probability that the number is a prime number. Okay, now let us go to the next example, simple example on probability, which is again based on the definition. The problem is like this. A card is drawn from a well-shuffled pack of cards. Find the probability that it is, first event is red card, second a jack, third a black queen, and fourth, the number on it is a multiple of 3. Now, when you are looking at the question, as I told you, look at the experiment first. So here the experiment is one card is drawn from how many cards? Well shuffled pack of cards. This knowledge you should have that it means 52 cards are there in the pack of cards. So one card is drawn. So my experiment here is one card is drawn from 52 cards. Now this number 52 is not given, but this basic knowledge about the playing cards you should have. And therefore, your NS is going to be 52 because 52C1 is going to be 52 as it is. So it is 52, NS is 52. And so your denominator for all the questions given below for finding the probability is fixed. It is going to be 52. Now you are worried about the numerator, and the numerator is NA. So we know that probability of any event is NA upon NS. My NS is fixed, and now the numerator NA will keep changing as my event A keeps changing from question to question. And it is actually an oral example. So red card. So again, you should have the knowledge key how many red cards are there. So normally in a proper or what you say impartial pack of playing cards, there are 26 red cards. So I will write here the answer as probability of red card is equal to, as I have written the definition of probability on the top, now you need not repeat it. You can simply write 26 upon 52, which is half. Then the second question is jack. So probability of getting a jack is, so I'm keeping the denominator as 52 everywhere. And now how many jacks are there? So there are 4 jacks, Gulam. So the answer is 4 upon 52. So it is 1 by 30. Then the third question is about a black queen. So probability of a black queen. Please note again in the bracket, I'm not writing the alphabet for the event, but I'm writing the description of the event as it is. Again, here the denominator is going to be 52. And now you have to count how many black queens are there. So as you all know, there are 2 black queens. So the numerator is 2. And therefore, this is 1 upon 26. And the last problem, now here you have to count the number on it is a multiple of 3. So probability that number is multiple of 3. So denominator is going to be 52. And what about the numerator? So again, I'm counting 3, then 6 also is there and 9 also is there. After that, in the table of 3, 12 comes, but 12 doesn't appear on any of the card. And therefore, you can have only 3 possible outcomes for the event that a number on the card is a multiple of 3. These are the favorable outcomes for the event that the number is multiple of 3. Again, it is not necessary to formally write the steps as let the event be number of multiples of 3. Let us call it as A. And then A is having this. This is all is happening in your mind. Okay. So I'm just skipping it, the steps, and final answer is numerator is 3. And that's all. So these are a few more examples on probability. The first problem is like this. A committee of 2 persons is to be selected from 10 persons, of which there are 3 lawyers, 4 teachers, and 3 doctors. 3, 4, 3 मिलके हो गए 10 पूरे. यहाँ तक का पार्ट जो है that gives you NS, as we discussed earlier also. Find the probability that, then there are 3 questions. I have left some space in between so that the solution can be fit in the space there itself. First question या first event बोल सकते हो. There is one lawyer and को note down, and one teacher. And then second question is find the probability that there is one teacher and one doctor. Third is both lawyers. And fourth is both teachers. Okay. So you are selecting 2 persons from 10 persons. So experiment is selecting 2 persons from 10 persons. And therefore, NS is 10C2. And just find out its answer. It is 10 factorial upon 2 factorial into 8 factorial. So 10 into 9. 8 factorial gets cancelled. I'm skipping some steps. It is 10 into 9 into 8 factorial, but that 8 factorial in the numerator will get cancelled with the 8 factorial in the denominator, which is सिर्फ 2 रहेगा. So it is 45. NS is 45. And then for all the remaining, for all the one minute. Yeah. So for all the questions given below, you will have the denominator NS as 45. Clear? Now we want to have one lawyer and one teacher. So see how we write it. Huh? Probability of one lawyer and one teacher. This is how we describe the event. So I write the definition of probability somewhere here, which will be used in all the 4 examples. So I need not write it again and again. When you are answering the descriptive theory type question, I say that please write the definition so that at least 1 mark of the definition you get, even if the calculation goes wrong. पण आता तसं काही नसणार आहे. फायनल आन्सर बरोबर आलं तर बरोबर, फुल मार्क्स. आणि तिथे थोडी देखील मिस्टेक झाली आणि चुकलं तर सगळे मार्क गेले. असं असणार. एनिवे, सो I was trying to tell you की and is intersection आणि मग तुम्ही काय करता, मल्टिप्लाय करता दोन प्रोबॅबिलिटीज. मग आता इथे काय करायचं, यू राईट द डिनॉमिनेटर as 10C2, okay, that is NS, and in the numerator what you have is now one lawyer. How many lawyers are there? 3 lawyers are there. From 3 lawyers you are selecting one lawyer. In how many ways? 3C1 ways. And आहे so into. One teacher is selected from how many teachers? 4 teachers. So it can be done in 4C1 ways. Okay, which is equal to 3C1 is 3, 4C1 is 4, and 10C2 is already calculated as 45. And what we get is 4 by 50 is the answer. Okay. So one teacher from 4 teachers, so 4C1, and one doctor from 3 doctors, so into 3C1. So numerator actually doesn't change only, isn't it? And therefore the final answer would be same. Has everyone got it? There are 3 lawyers, तिघांमधनं 2 आले, and denominator is 10C2. So I know the denominator is 45. Now this 3C2 you can calculate in the rough work. Actually no need of calculation. 3C2 and 3C1 are same. Why? I have this formula. NCR and NCN minus R are same. Therefore 3C2 and 3C1 are same, and which is equal to 3. So you actually don't need the C का formula. यहाँ से directly आ जाता है. So the answer is 1/50. Okay. So probability of getting both teachers, since there are 4 teachers, numerator would be 4C2 divided by 10C2, that is NS. And after calculation, you get this answer. Now box contains 5 blue and 4 red balls. And 4 balls are selected at random from the box. यहाँ पे experiment और NS का part खत्म होता है. Correct? So you can write. कोणाचा mic चालू है? Mute करा. Okay. So experiment is, so in all, how many balls are there in the box? There are 9 balls. So experiment is 4 balls selected from box containing 9 balls. And therefore your NS is 9C4. Correct? So calculate केलं तर हे येणार 9 factorial divided by 4 factorial into 5 factorial. So I break the 9 factorial up to 9, 8, 7 and 6. Okay, let me write 5 factorial, 4, 3 and 2 and 5 factorial, and then this gets cancelled. And now I can reduce. Now 972 किती येतात? 9 63 दुने 126. Correct?
Yes.
So it is 126. Okay, so that is my denominator for both the questions. Now, as per the question, that is as per the event, my numerator will change. Now, in the first part, the event is exactly 3 red balls. So these 3 red balls will come from these 4 red balls. So 4C3 is my numerator. Okay, so I write probability of 3 red is, by the way, प्रोबेबिलिटी का डेफिनेशन लिख के रखो हमेशा की तरह इधर. So you know that which definition or rather which formula you are making use of. इधर बाजू में लिख के रखा है. Now using the formula, now 3 red balls can be selected from 4 red balls in 4C3 ways, and in the denominator you have 9C4. So 4C3 कितना आएगा? 4C3 is same as 4C1. So ये आएगा 4 और इधर आएगा 126. Okay. म्हणजे किती येणार? 2/63. Correct? You can calculate in the decimal also if you want. This is clear? माझ्या calculations cross check करा. Because when I'm solving the problem, माझं screen वर fit होतंय ना, pen change करायचं की नाही दिसतंय ना, इथे जास्त लक्ष असतं. So I may make a mistake in calculation. So, how many of you have scientific calculators with you? Now, what is at least 3 red balls? चारातनं at least 3 रेड आले पाहिजेत. हे जे 4 आहेत, या चारात at least 3 रेड पाहिजेत. बरोबर? So now, how one can do this? Thinking, this is my thinking. Now this 4 balls. At least 3 म्हणजे काय? 3 or more. At least म्हणजे कमीत कमी. कम से कम 3 चाहिए. मतलब 3 भी चलेंगे या ज्यादा भी चलेंगे. ज्यादा यानी कितने? सारे के सारे 4. So इधर 2 तरह से ये हो सकता है कि 3 रेड है एंड चौथा कौन सा आएगा फिर? ऑफ कोर्स ब्लैक आएगा. एक ब्लैक आएगा. करेक्ट? या फिर या और क्या हो सकता है? All 4 are red. All 4 are red. Okay? 2 तरह से ये इवेंट हो सकता है. You want to get at least 3 red balls, ना? So from 4 balls, at least 3 red can be done in these 2 ways. तो इसमें से एक तो ये हो सकता है और ये हो सकता है. तो यहाँ पे मैंने एंड और कैसे यूज किया है समझ में आया सबको? I repeat my explanation that at least 3 red balls means 3 or maybe all 4 are red. So 3 red balls from 4 red balls can be selected and the 1 ball which is remaining is a black ball. Correct? Or what you can do is all 4, कम से कम 3 चाहिए तो चारों के चारों red आए तो भी चलेगा. All 4 can be red balls. This is how it happens. Okay? और ये 2 events एक साथ नहीं हो सकते. That is one thing. They are mutually exclusive. अगर ये हुआ तो ये नहीं होगा. ये हुआ तो ये नहीं होगा. So they are mutually exclusive. Okay? अभी हम क्या करेंगे? सिर्फ and और को मल्टीप्लिकेशन और एडिशन से रिप्लेस करने वाले हैं. तो इसको देखो डायरेक्टली हम कैसे सॉल्व करते हैं. तो प्रोबेबिलिटी ऑफ एट लीस्ट 3 रेड. ओके, यहाँ लिखती हूँ मैं नीचे. टू बी 9C2, सॉरी 9C4 जो हमने ऑलरेडी देखा है पहले, बिकॉज 4 बॉल्स आर सिलेक्टेड. अभी एटलीस्ट 3 रेड यू कैन हैव 4 में से 3 रेड आए. मिनट, 4 में से 3 रेड आए, जैसे ये 3 रेड एंड है तो इनटू एक बचा, वो कहां से आया? ये 5 ब्लैक में से. सो 5 में से 1 आया. ओके, एंड है इसलिए मल्टीप्लीकेशन किया. और एक तो ये हो सकता है और मतलब प्लस हो गया. क्या हो सकता है? चारों के चारों बॉल्स रेड में से आ सकते हैं. तो चारों के चारों रेड में से, और रेड कितने हैं? 4 है. दैट्स ऑल. और बचा ही नहीं कुछ, तो कुछ सवाल ही नहीं आता है दूसरा पार्ट लेने का. हम this is how the numerator will become. This is my rough work, and remember the word and is used by multiplication and or is used by addition. 9C4 was 126 as we have calculated already. 4C3 is same as 4C1 and therefore it is 4. 5C1 is 5 and 4C4 is 1. So it is 21 upon 126, which comes out to be 7 upon 40. So 1 by 6. Correct, no? Yeah,
Yes, ma'am.
1 by 6. That is my final answer. 2 cards are drawn from a full pack. Full pack, we can be specific by saying a full पॅक ऑफ 52 कार्ड्स, पण नसेल जर दिलेलं तर तुम्ही अज्युम करायचं की 52 कार्ड्सच असतात, त्याच्यामध्ये जोकर नसतो. व्हॉट इज द प्रोबॅबिलिटी दॅट दे आर बोथ स्पेड्स अँड वन स्पेड अँड वन हार्ट? तसं म्हटलं तर खूप सोपा आहे प्रॉब्लेम. सो एक्सपेरिमेंट, 2 cards drawn from 52 cards, and therefore NS is 52 C2. आता तुम्ही काय one by 17. Book is giving the answer 1 by 17. Let me cross check. Yeah, it is correct. Are you all getting it? This is my rough work. इधर मैंने 588 को राउंड ऑफ करके इतना लिखा है, और you can also write the final answer as 1 by 17. Probability of अभी के अभी इधर भूल जाती हूँ. Spade and heart. Okay. Probability of 1 spade and 1 heart. So denominator तो यही रहेगा 52 C2. Now how many spades? 13 में से एक आया, and है इसलिए into 13 में से और एक आया. So 13 C1 is 13. ये दूसरा भी 13 अपॉन ये है मेरा 1326. Now here also you can use the calculator and get the answer. I'm doing the same thing.
.128.
Yes, 0.128. 0.128 is the final answer. This is how the second part of the question is also solved.